Okay, good afternoon. I am going to make a brief presentation of our research nuggets that we have been doing in the last 10 years and some of the issues that we have and maybe some potential collaboration. I will talk a little bit about parallel distributed simulation. One evolution of that called multiple resolution modeling and some of the applied artificial intelligence work that we are doing. Overlap is the simulation interoperability laboratory. I call it here building the future from the land of industrial engineering. I am a professor. I started here at UCF in 2001. I have been 22 years here at UCF. And I am also the undergraduate director of industrial engineering. Therefore, we shouldn't be doing so much research, but we like to do research. Therefore, when we go to sleep, we do research. We have a bachelor in electrical and mechanical engineering from the Technological University of Panama. We have a master in electrical, another one in engineering management, and we have a dual master in systems engineering and management from the MIT Sloan and the MIT College of Engineering. I have a Ph.D. in engineering management and I have some postdoctoral studies in nuclear. Therefore, my research areas are distributed simulation, optimization, and applied AI in general. I teach senior design and also I teach system simulation. We have been able to bring around $4 million in sponsor research from different entities. I teach the capstone senior design, and we have had more than 200 projects with companies. And we are a member of the Dean's Initiative in iDesign, that is interdisciplinary design of all the different departments in the college. We have 3 patents in artificial intelligence that flies in commercial and military airplanes, around 300 articles, 3 books, and I have a Google Scholar of 3K plus that for IE is considered outstanding level because we are a small community. Industrial engineering is a very small community. We have been advisor and co-advisor of 54 PhDs, 45 masters, and 3 postdocs, and some international recognition awards. Yes, as I said, even though we have some administrative parts, we like to have a balance academic professionally between research, and we do simulation because simulation, Orlando is the world capital of simulation, and our research park is based on that. And simulation artificial intelligence have been recognized by the Office of the President, by the DoD, important areas to keep our technology supremacy. And of course, we like to contribute to STEM education and have participation in the international community. Parallel distributed simulation, discrete event simulation emphasis. Basically, we have several collaborators here, and some companies here from the research park. And when we started to learn in 2010, 2011 about deep learning, we contacted Dr. Geoffrey Hinton, and he helped us to learn a little bit more, and our sponsors. We were the first unit in the college that had research with a foreign entity that the U.S. State Department, based on advice from the Pentagon, gave us some special permission to have that project because it was military related. Therefore, we have a specific contract, a DSP-5, that is more than ITAR level, basically. Basically, what we do is we put different type of simulations together using a military platform called the high-level architecture, and we are able to put all of those simulations together in a way that they are tight, coordinated in time, logic, space, and the interesting thing is in that architecture, we have been able to adapt accelerators that use high performance components. It's like a coprocessor, but it's a parallel processor that implements conservative and optimistic ways to do the computation. For example, you are doing many simulations and you need to use a component of a training in deep learning. Therefore, you throw it to us, you throw it to the accelerator, and the accelerator can use elements of deep learning in order to make the configuration of the accelerator based on the node. We have been using this, and these have been funded to analyze weapon system effectiveness, and very successful. And again, with a funding of around $1.5 million in this area in the last 10 to 12 years. And here in the video, you can see different elements. For example, in one computer, we can simulate a destroyer, and in other component, we can simulate an MIG, an squadron, and see the interactions. These are simulations of several degrees of freedom and thousands of differential equations, and we can gather data. In this case, we basically in the range of big data, and also on structured data that is the opinions, and we can analyze them using statistics and, for example, all of these, and also using artificial intelligence. Another area is based on that, the multiple resolution modeling is how to connect models at different levels. And this is a holy grail from the military. Basically, in the military, we have the campaign level. Of course, example like Desert Storm is at the campaign level. We want to simulate that. That has a level of resolution, but then we want to simulate at the mission level. We want to simulate a battle. We want also to simulate at the engagement level, an F-35 engaging a MiG 21, and also at the engineering level, a radar, for example, a weapon system. How to communicate all of that. That is the holy grail that nobody has been able to accomplish. And we have been studying in the last 8 years this type of multiple resolution modeling. And again, we go to high-level architecture. And for several years, we study and we develop our own recipe how to build MRN systems. This is the only one that exists right now. Basically, this was experience from 3 or 4 years building different type of multiple resolution modelings based on other people's techniques, but learning from that and how to put it together using our own approach. Basically, that recipe, you have to decide what type of simulation, if you are going to build the simulation or you are going to use legacy models. Then we do some recommendations. After that, you go to another step, how is the federation architecture? Are you going to use a centralized approach, or you're going to use a fully distributed approach or a partial distributed approach? And then you go into design a regulator. That is a type of artificial intelligence decision making. And that regulator is, where are you going to put that regulator based on ontologies, as I said, or some rational AI? And then what? How the transition management in that MRN configuration? How is the data consistency, and how is the time synchronization? And then that recipe helps you to create your own multiple resolution model. And it's the only one that we know, and we have had some experience with that. Another area is about AI-based schemes for logistics and resource allocation. We have many collaborators here. We have been working with the MIT Center for Logistics, the MIT Center for Collective Intelligence, and we have had some sponsors, L3 Harris, US Space Force, the National Science Foundation, and basically we are trying to we have used deep reinforcement learning in certain fashions to help us to do the optimization and combine it with the standard operation research, and again simulation always behind this. Again, therefore, in the near future, we are expecting to continue working with the South Korean government. And in this case, they have requested us to write a proposal about the famous teaming pilots with drones. Still, it's not so clear where should be the AI of the drone. If it's embedded in the drone, or it should be in a remote, very powerful computer, what should be the functions of the pilot? That is something, and right now the majority of the experiments, high-level drones, are using F-16s as drones, and we are ready for that type of research. Why? Because already we have the infrastructure, we have already the experience with HLA, and some of our students are F-16 pilots from the Air Force, United States Air Force, or the South Korean Air Force. We are going to get an extension of the U.S. Space Force, maybe more than 100K in the near future. Companies are interested in that too, in the logistic part. And also we got the first phase from the NSF, and we are going for the second phase. We are going to increase our collaboration, and hopefully in the next 10 years, we have a higher Google Scholar of 6K plus, and we get more money into the funding and more international collaboration.